This is the video for section 10.2, but first of all we are going to recall a theorem from chapter 5. It's called the total change theorem. We discussed it when we were talking a little bit about the fundamental theorem of calculus. When you take the integral from time 1 to time 2 of a rate of change formula, the answer is going to just be the total change over that time. So if this had been a velocity equation, this would be the total change in displacement over that time. So for example, at 7 a.m., water begins leaking from a tank at a rate of 2 plus 0.25 t gallons per hour. T is hours after 7 a.m. How much water is lost between 9 and 11 a.m.? And so because this is a rate of change in gallons per hour, we're just going to do the integral of that. And remember, T is hours after 7 a.m., so 9 a.m. is 2 hours and 11 a.m. is 4 hours after 7 a.m. So we have to do the integral from 2 to 4 of our rate of change, and we have lost 5.5 gallons over those 2 hours. And so this was the integral of a rate of change, and the total change in the amount of water was 5.5 gallons. So section 10.2 is going to cover distance versus displacement for linear motion. And so we're going to decipher the difference between these two when it comes to our integrals. So recall the integral of velocity from time 1 to time 2. You could also have it as s prime, so the change in position, or the rate of change of position, is just going to give us that net change in position from time 1 to time 2. And so the difference between displacement during those times and total distance traveled is your displacement is just the integral, everything that we've been working with from time 1 to time 2 of your velocity equation. But your total distance traveled, you have to take into account that if an object turns around, you have to count that as the total distance traveled. But when it comes to displacement, we subtract it. And so the total distance, the difference in the formula is that we're going to take the absolute value of velocity. So here's a graphical example. If we have a graph of velocity and where some of the velocity is positive, some of it is negative, the displacement from time A to time B is just going to be the area of the pink A sub 1, and then we're going to subtract the area A sub 2, and then we'll add A sub 3. But if we're talking about the total distance traveled, this object it has positive velocity, means it's moving away from its reference point, and then it has negative velocity, means it turned around, and so we're going to count that as distance traveled, and then it turned around again to go away from its reference point. And so the absolute value from A to B would just be adding all three areas, ignoring that A sub 2 is a negative velocity. So an example, it says an object, moving object has velocity v of t equals t squared minus 7t plus 10 in feet per second, and we're only focused on the interval from 1 to 4. So the first question is, find the time sub-intervals, so what times in between 1 to 4 seconds is the velocity positive and where is it negative? And then what does this mean the object is, doing? So because we want to figure out when its velocity is positive and negative, the first thing is we need to figure out when its velocity is 0. So set the velocity equation equal to 0. This one is factorable to t minus 2 and t minus 5. Therefore, using zero product property, the times that the object is stopped or paused is at 2 seconds and 5 seconds. And so then in order to know whether it's the intervals and whether it's positive or negative, it's kind of like the first derivative test. So since our interval starts at 1, we're going to figure out what's it doing from 1 to 2, and then we're going to figure out what is it doing from 2 to 4. We don't have to worry about this 5 seconds because it is outside our interval. So what's it doing from 1 to 2? What's it doing from 2 to 4? Figure out what the velocity is, and then that's going to tell us what the object is doing. And so if you plug in a value between 1 and 2, so like 1.5, you're going to get a negative times a negative. You end up with a positive. That means the object is moving forward. If you plug in a number between 2 and 4, for example, 3 seconds, when you plug that in, you get a positive times a negative, which is a negative velocity. That means the object is moving backwards. So it says find the displacement and the distance the object travels in each subinterval. So the first thing is we're just going to go from 1 to 2 just of the velocity, not the absolute value. So you can plug in the velocity equation into your y1 and then just do your math 9 of y1 from 1 to 2 and you get 11/6 as feet as the displacement from 1 to 2, the change in displacement. And then if you're trying to find total distance traveled, since we need the absolute value, you're going to hit your math 9 button, but then you're also going to hit the math button, arrow over to number, and then the first option is the ABS for absolute value. And then make sure you do the absolute value of your y1 from 1 to 2. And it is going to be the same answer because this is where the object was moving forward. Then check the interval 2 to 4. When you plug that into your calculator, you get -10/3 feet, meaning the object moved backwards. But if we're talking about the distance traveled in that interval, it's going to be a +10/3 feet. And then the other question is find the displacement and the distance traveled, or the object travels in the interval 1 to 4. So if we just set up our intervals from 1 to 4, the displacement, the total change in displacement is -1.5 feet, meaning the object moved closer or moved backwards from towards its reference point. Another way you could have found this was just taking the 11/6 minus the 10/3, and you'd get a -1.5 feet. The absolute value from 1 to 4, so the total distance traveled would be adding the 11/6 plus the 10/3 feet, and 31/6 feet is the total distance the object traveled. A second example I have is a toy car has a velocity given by this v of t, 0.2 times t minus 4 to the third times t minus 1. V is measured in feet per second, and position is from the door, and t is measured in seconds on the interval from 0 to 6. And at the initial time, the car is at a position of 0 feet. And it says answer the following questions. So you can pause the video at this time and try to answer these questions and then come back for the answers. So number 1 is when is the car stopped? And so what you're trying to figure out is when its velocity is 0. So you set this equal to 0. This one is already factored, so I can tell using zero product property that it stopped at 1 and 4 seconds. And then when is the car traveling forward and when is it traveling backwards? This kind of goes to the first derivative test. You have to check the interval from 0 to 1, from 1 to 4, and then from 4 to 6. So when you plug in a number between 0 and 1, so like 0.5, you're going to get a negative times a negative, which is a positive. Plugged in a number between 1 and 4, you're going to get a negative times a positive, which is a negative value. And then from 4 to 6, you're going to get that positive times a positive. And so the car is moving forward from 0 to 1 and 4 to 6, and it's moving backwards from 1 to 4 seconds. Third question was, what is the car's total distance traveled in the forward direction? So this would be using the absolute value from 0 to 1 and then adding it to 4 to 6, and you get 8.67 feet. The car's total distance traveled in the backwards direction from 1 to 4, the absolute value of that, you get 2.43 feet. So remember, with total distance, you're using the absolute value of the velocity. I had a couple other questions that weren't on that first slide, so you can pause again. It says, what is the total displacement of the car? So this would just be the integral from 0 to 6, but with no absolute value. You should end up with 6.24 feet. And then what's the total distance traveled by the car? That would be the absolute value from 0 to 6, and you get 11.1 feet. And so another way to find that displacement was taking the two numbers that you found in 3 and 4 and subtracting them, because one was this was the total distance in the forward, and then the total distance in the backwards direction, so that would be a negative displacement. With total distance traveled over the 0 to 6 seconds, you have 11.1 feet. You could have added those two numbers that you found in 3 and 4. Two more questions that you might see when it comes to position, velocity, and acceleration is, what is the car's position when it first changes directions? Well, we know that the first time it stops is at 1 second. It's moving forward from 0 to 1 and 4 to 6, and it's moving backward from 1 to 4. So t equals 1 is the first time it changes directions, but that's not what the question's asking. It says, what is the car's position when it first changed directions? So we know at 1 second it changed directions first, so now we just plug this into our integral, we're going to go from 0 to 1 because we don't have the position equation. So we're going to do the integral of the velocity from 0 to 1, and the position at 1 second is 4.99 feet. And then the last one is, what is the maximum position of the car? This comes down to finding, the absolute max using the extreme value theorem. So that closed interval method, we're going to plug in our critical points that we found, which originally were 1 and 4, then plug in 0 and 6, and see just which one has the largest y value. So S of 0 would be doing the integral from 0 to 0, which we also originally told you that the initial position was 0 feet. Plugged in 1, which we got up here in number 7, 4.99. And then find the position at 4 seconds. We do the integral from 0 to 4. You should get 2.56 because remember it moved backwards from 1 to 4 seconds, so it's not going to be as far as it was at 1. And then S of 6, do your integral from 0 to 6, no absolute value, and you should get 6.24 feet. So the maximum position is 6.24 at 6 seconds. So try this practice problem on your own. An object has an acceleration given by a of t equals 2 cosine of t in feet per second squared on the interval from 0 to 2 pi with an initial velocity of -1. Find its displacement and the distance traveled on the interval. We will go over this problem in class next week. A couple things to pay attention to when it comes to critical points. It says if a moving object comes to a stop, several things can happen. You don't want to assume that just because velocity is 0 that the object changed direction. So here's an example of an object moving. The cubic is the displacement, the parabola is the velocity. You have your critical point, so this horizontal tangent line. This would be an example of where the object pauses. You have a derivative of 0, but then it keeps moving in the same direction and the derivative does not change sign. So this graph, my velocity is positive, then it's 0, and then it's positive again. So this critical point ends up being a point of inflection. So the object paused, stopped, and then just kept going in the same direction. It did not turn around. Another thing that can happen when a moving object stops is that it does stop and it changes direction. So the parabola is the displacement and the linear function is the velocity. So here's your critical point. That's your horizontal tangent is 0. So the object stops, its derivative is 0, and then it changes direction. So the derivative changes sign. So here we have positive. I just realized the derivative graph is incorrect. But we have positive slope, so the velocity should be positive, and then it's negative. So this line is backwards. Awesome. And the third example that I have is an object doesn't even stop or pause. So you have an object that's moving, and then all of a sudden it just changes directions without stopping or pausing. So the velocity instantly goes from negative to positive. The best example that I can think of would be a baseball being pitched and then being hit. So the pitcher pitches it at 80, 90 miles per hour, and then the batter hits the ball with the bat, and that ball does not stop or pause. It instantly changes direction and changes velocity. So this is where you have a critical point, but you have an undefined slope. And so the object changes direction without stopping or pausing. So those are the three things that can happen when an object comes to a stop. Here is your optional assignment. It's on page 505. Numbers 2, 4, 5 to 11 odd. I suggest doing a couple of these just to practice finding the difference or the displacement of an object versus the total distance it traveled. We can go over these in class next week. Otherwise, there will be some of these problems on your review sheet for your test, which is available on Moodle right now. Have a good night.